Every time you've ever ordered something online, there's a good chance your payment, your confirmation email, and your inventory update all happened in completely separate systems, none of them waiting for each other. That's a message queue at work. A message queue is a system that holds work to be done, temporarily, so that the part of your application creating work and the part doing that work don't have to operate at the same speed, or even at the same time. Think of it like a restaurant ticket rail. The server writes your order, clips it up, and walks away. The kitchen takes tickets when they're ready. Neither side is blocked waiting on the other. The ticket sits there until someone handles it. That's exactly what a message queue does, except instead of food orders, it's data. Without a queue, your systems talk directly to each other. Service A calls Service B and waits. If Service B is slow, Service A slows down. If Service B crashes, Service A crashes. This is called tight coupling, and it's where distributed systems fall apart under real load. Say you're running an e-commerce platform on Black Friday. Orders spike. Your email notification service can't keep up. Without a queue, those failures ripple upstream and orders start failing too. With a queue, the email service can fall behind, recover, and process at its own pace, and the order system never knew there was a problem. That's the moment teams learn the difference, usually the hard way. Here's the actual mechanism. You have three players, a producer, a queue, and a consumer. The producer is whatever generates work, a web server, an API endpoint, a microservice. It creates a message and drops it into the queue. The message is just structured data, a JSON object, a binary payload, whatever your system agrees on. The queue itself is managed by something called a message broker, software specifically designed to store, route, and deliver messages reliably. Apache Kafka, RabbitMQ, and Amazon SQS are the three you'll hear constantly in back-end engineering conversations, and they have genuinely different philosophies. RabbitMQ is a traditional message broker built around the AMQP protocol. Messages go in, get routed based on rules, and are deleted once a consumer acknowledges receipt. Simple, reliable, widely used. Amazon SQS is a fully managed cloud service. You don't run any infrastructure yourself. Messages sit in the queue for up to 14 days by default, and consumers poll for work. At least once delivery means a message might arrive more than once, so your consumer needs to handle that gracefully. Kafka is different in a fundamental way. It's a distributed event log. Messages are written to a topic. Think of a topic as a categorized stream, and they're retained for a configurable period regardless of whether a consumer has read them. Multiple independent consumers can read the same message. That pattern is called pub/sub, short for publish subscribe, and it's the foundation of event-driven architecture. In Kafka, you configure things like retention, DMS to control how long messages live, and consumer groups to coordinate which consumers handle which partitions of a topic. Partitions are how Kafka achieves horizontal scale. Work is spread across multiple parallel lanes. And if this is the kind of under-the-hood explanation you want more of, Stack Future covers one concept like this every day. The consumer reads from the queue, processes the message, and sends an acknowledgement back to the broker. If no acknowledgement arrives, because the consumer crashed, the broker redelivers the message. That's how these systems guarantee work doesn't get silently lost. You're building a user registration flow. When someone signs up, your API needs to send a welcome email, create a record in your analytics system, and trigger a Slack notification for your team. Without a queue, you call all three services synchronously. One timeout and the whole registration fails. With RabbitMQ, your API publishes one message to an exchange with the routing key user.registered. You've configured three separate queues bound to that exchange. Each downstream service consumes from its own queue independently. Your API responds to the user in under 50 milliseconds. The email goes out 2 seconds later. The analytics write happens whenever that worker gets to it. If your Slack integration goes down over the weekend, the message sits in the queue. Monday morning, the consumer comes back online, processes it, and acknowledges no data lost. No one had to write retry logic in the API layer. Message queues decouple the systems that create work from the systems that do it. And that separation is what lets distributed systems stay stable under real-world conditions. The broker stores the message, the consumer acknowledges it, and failure in one place stops being failure everywhere. Next video, OAuth 2.0. Exactly what happens behind the scenes when you click Sign in with Google. If that one was useful, a like helps more people find it.